Hi everyone, hope you are doing good. So if you are seeing my tablet screen, from the text which is available, which is written on my tablet screen, you might have already guessed the topic for today's video. So I have here written that today's topic is about understanding storage in data engineering. Okay, so obviously, yeah, today's topic is about like understanding the storage in data engineering. So we are going to understand a little bit more deeply about storage. And I would say most people think like storage is just about like just taking the data from source systems or from wherever it is getting generated and then putting it into some place. Yeah, you can say it is that simple, but then at the same time there are so many nuances one need to understand in order to completely get whole picture of storage. Okay, but before starting or before like completely diving deep into today's topic, let's maybe let me ask you a simple question. Okay, so if you have to store all the data your company will generate for the next 5 years, so where would you put it? Okay, so if I ask you that question, like if you have to store all the data that your company is going to generate for next 5 years, where would you put it? Okay, so many people what they will do is they will immediately answer that question with a tool. Okay, you might have on the back of your mind you might already be thinking about like a Snowflake or S3 bucket or ADLS or blob storage or BigQuery or or data lake or data warehouse or any relational database or something like that, right? Because we have like so many places, so many things to store the data. Okay, we have basically RDBMS, relational databases, and then we have data warehouses, we have data lakes, and we have lake houses. And then if we talk in terms of like tools and technologies, um, we have basically Snowflake, right? So we have basically Snowflake or BigQuery, yeah. Or if it is Fabric, we have like I don't know, One Lake maybe, yeah. And then if you talk in terms of object storages like file systems, we have GCS, Azure Data Lake, and then we have blob storage or S3, or we have a lot of different things where we can store the data. So if I am asking you the question like where do you put all your data, all the data that your company is going to generate in next 5 years, so I'm sure like pretty much many of the people will answer it with some kind of technology or some tool name probably. Okay, but I won't say that's wrong. Okay, but also I would say that's not the right way to think about it. Okay, let's put it that way. So because I would say uh, probably like unfortunately like most of the junior data engineers or mid-level data engineers or people who are just entering into data engineering, they will think in terms of technology. But then you kind of have to think whenever you get a question in real world, you kind of have to think in terms of basics, fundamentals. Okay, and that's what we are here to understand for. Okay, so now you kind of know that we have all these different storages available, but then which one to choose from. Okay, so this video is basically about understanding all that nuances. How do you pick what kind of storage to store your data from, and then what are the factors or what are the key things that you basically need to consider in order to before choosing a technology or before choosing a tool that you need to store the data. So let's understand that. But but then if you ask some kind of senior or principal or staff data engineer or even the data architect the same question, okay, if you ask them the same question like if you go to the data architect in your company and if you ask them like, okay, where do you so we are going to like get so much data in the next 5 years, so where do you store it? And then probably what architect would do is the architect, maybe if he's like proper good architect, okay, then probably I would expect that he don't start with the tool, he don't start by saying the tool names out loud, okay. They will probably ask you like more questions, like they will probably ask you, okay, what are the requirements, for example, okay, what are the requirements and what are the constraints that we have to deal with, okay, and also basically what are the uses or access patterns, okay. So if you go to senior data engineer, or if not senior, some principal or staff data engineer, and or else if you go to data architect and if you ask them the same question like, okay, architect, now our company is going to, let's say our company is going to generate like so much data in the next 5 years, where should we store that data? And then they will probably ask you so many different questions, before talking about any kind of tool or technology, okay. They will probably ask some questions like, what are the requirements and what are the constraints that we have to deal with, and then what are the uses or access patterns, and then they will go talking a little bit more about the tool, and or a little bit more, they might ask you more questions about the requirements and then come to the tool, okay, with a proper justification. because because the truth is, um, data storage is not at all about like choosing the right product or right tool. Of course it is about like choosing the right tool, but then in order to choose the right tool, you kind of have to know what are the requirements that you are dealing with, okay. So I would say it's not at all about like choosing a product. It's mainly about choosing the right behavior for your requirements, okay. So what I'm saying is, I'm saying it's not about choosing product. I'm not saying that, and I'm saying it's about choosing the right behavior. This is the keyword here. We are going to talk, of course, more about what is the behavior that we are emphasizing here. So, but what I'm saying is, I'm saying data storage is literally not about choosing the product. Okay, it's mainly about choosing the right behavior for your requirements. Okay, and basically if you understand the behavior of the data, okay, so you might get doubt, you might already be thinking, okay, Harsha is mentioning a lot about like behavior, okay, what does behavior with respect to storage, okay. So I'm saying like if you understand the behavior of the data, when I say behavior, behavior of the data in the sense, for example, like how often it is getting accessed, right? So how often it is getting accessed, yeah, and then how fast it grows, okay, how fast it grows, the velocity the data can get generated, and the volume, you know velocity and volume contributes to how fast it grows, and then how accurate it must be, how accurate means how much correctness should be there in the data, and then who will consume it, who are the consumers, who will be the consumers for this data. Will it be like your Power BI reports or dashboards or Tableau reports, or will it be some analytics jobs, or will it be like some some kind of event driven systems, okay, or will it be like some kind of live reporting or something like that, okay. So you should understand who will be your data consumers, and then you should also pay attention to what kind of compliance rules exist, okay. You should also pay a little bit attention to, not little bit actually, quite a lot attention. You should also pay a lot of attention to compliance rules and all that stuff, okay. because um, because if you understand the behavior of the data, and then take the decision towards the tooling, then only storage decision becomes like logical, instead of like randomly taking the decision like, oh, now we are going to use Snowflake for putting our data, or we are going to use S3 buckets for putting our data, or blob storage for putting our data. Instead of thinking not in just terms of tools and technology, if we understand, if we focus more on the behavior, okay, behavior, like if we understand the data behavior, like how often, okay, it is going to get accessed, and how fast the data is supposed to grow, and how accurate it must be, and who are the consumers of this data, and what are the consumption patterns, and then what should be the compliance roles that the storage system must support, right? So you should have, all these, you should basically get all the answers for this questions, like before you choose to go with any kind of storage system or technology, right? So so today of course, like we are going to like break down more, little bit more about this, storage in data engineering, and we'll of course understand key constraints, and we'll see what will happen if you don't pick the right storage system for your requirements. And then of course we'll also see the most common storage systems or technologies that we have available, and then when to pick them as well. So we are going to discuss all that in today's video. So let's understand why storage matters at all in first place, right? Let's understand why storage matters at all. Yeah, so what kind of, you might be wondering, like what kind of question is that? It's just it matters because we need to store the data somewhere, right? Of course, yeah, it is that simple. So, but I would say like storage is not just a place to like keep the data. It literally influences, how fast your data ingestion pipelines or transformation pipelines run, or how much money you are going to end up spending, or in order to store the data, and how fast your data analysts can access the data, or your reports can fetch the data. And then even for like from scientists perspective, it will be like, it will also make sense that how easily machine learning models can be trained, and then how future proof your architecture becomes. Okay, so all these things, like your storage basically influences all these things. Okay, let's actually list down like what are all the things like the storage can influence. Okay, so we are saying basically how fast storage influences how fast your pipelines basically run. So of course, I'm going to say how it will influence the speed of your ingestion and transformation pipelines as well. Okay, so if you don't pick the right storage for the right job, then obviously it is going to influence. But we are going to talk about it, a little bit more with the examples. But let's maybe wait for like 5 minutes before we get there. Okay, so. But why storage matters is, I'm saying like, of course it matters because we need to store the data somewhere, but it's not just about like for storing the data, because it influences how fast our pipelines will run. And then I'm saying it will also influence the cost or pricing. Okay, so obviously like whenever we work in cloud or wherever we work, no one will give away the cloud storage for free, right? We need to pay the money. Okay, but then the pricing can vary from storages to storages. Okay, so we are going to talk about it. So depending on the type of the storage system you pick, the pricing is going to vary, obviously. And then it will also influence how data analysts, okay, how data analysts basically can access the data. So, and then it will also, of course, influence how easily, how much easily machine learning models can be trained, right? Because obviously you have to use data in order to train them, right? So obviously it will also influence this thing. And then of course The most important point I want to emphasize is it will also influence how future proof your architecture becomes, your data architecture becomes, or your platform becomes. Okay, how future proof your architecture becomes. Okay, it will influence all these things, and actually, you know what, it is going to influence so many more other things as well, but these are some of the things like that it will influence for sure. And then I want to emphasize more on the last point. Okay, so which is um, how, so it will literally silently influences how future proof your architecture becomes. If you don't pick the right storage, sometimes storage decisions can be irreversible. And irreversible in the sense, of course, nothing can be reversible, everything is irreversible, I believe. But at the same time, you might end up spending like a lot of time, a lot of your time, time and energy, like migrating, your data and your workloads from one storage to another storage. If you don't pay attention to all the all the things that matters, like while picking the storage, like you need to pay proper attention to requirements, constraints, and usage and access patterns. And then you need to pay attention to the behavior of the data, like how often it is getting accessed, or how fast it grows, and how much accurate it should be. And of course it should be accurate, but and then who will be the consumers, and what kind of complaints rules it should support. So obviously all these things matters, guys, and it obviously influences all these things. So you need to like literally pay so much attention to this. Okay, and then of course these are some of the things we need to pay attention, and then we need to be wary of. um, and then maybe also let's maybe get the fundamental definition of storage right. Okay, um, so so basically, what is the most fundamental definition like that I can give for storage is, basically storage is where the data lives after it is generated from source systems. After not generated, storage is basically the place where the data lives after it's collected from source systems. Okay, so so that is the most fundamental definition that I can give for like data storage. Okay, it's basically the place where your data lives after it is being collected from source systems. You need to remember that. Okay, and now let's talk about most common types of storage. Okay, so yeah, of course. So uh, so there are of course like all the different so many types of storage systems like available. Some Now we are going to talk about like some of the common ones. Okay, so let's talk about them. The most common one first we should talk about should be like object storages. So when I say object storages, then they are like basically S3 buckets, or blob storage, or even GCS. So these are some of the object storages, and then um, and then let's start. Let's actually, you know what, list down all the common storages, and then we'll see when we have to use them, or when we have to pick them, or what's the purpose of that storages, that storage types. Okay, let's see. So the first common one is object storage, which is for them example would be S3 buckets, or blob storage, and or GCS. And then next one you get to hear a lot if you are a data engineer, or data scientist, or data analyst, or any report developer. If you are working close to data, then you probably would have heard a lot about this one, which is data warehouse. Okay, so when I say data warehouse, there are so many things obviously, but here I am going to list a little bit more popular ones nowadays. It can be Snowflake, or it can be Redshift, or it can be like BigQuery, um, or for on-prem guys it can be like Apache Hive. Okay, um, Yeah, there are so many more actually. Um, so these are some of the most common data warehouses. Okay, and then other one we need to talk about is databases. Okay, so obviously I think I suppose like everyone knows about the data warehouse databases, right? For example, good examples of this would be Postgres, and then for example SQL Server, and then maybe MongoDB as well, you know. uh, yeah, and then etc etc. Obviously there will be more, and then not there will be more, there are for sure more, definitely. And then the next most common type of storage we need to touch upon is data lake. Okay, data lake are also basically lake house. Okay, so this is also one of the common one. And then here maybe you get to hear about like HDFS, ADLS, and then underlying they have like a common storage format layer. For example, that would be like Delta Lake or Apache Iceberg or Hoodie and all these things, right? And then maybe you know what? Let's talk about like a little bit of streaming retention storage as well. Okay. So yeah, especially in this modern age, modern digital age, you get to also see this a lot. And then here we'll maybe say Kafka, Pulsar, and all. Okay, and then actually so if you have to see the purpose, okay, purpose of each and every storage. So the purpose of the object storage would be like it is basically cheap. Object storage is like really cheap and scalable. Okay, right? And you can use it as a like store, you can use it as a place to like store multi-purpose data. Like it can handle like structured and semi-structured and all different kinds of data. And then most of the time it is kind of used for raw or bronze layer, or people also use it for archival processes as well. Okay, and then when we talk about like data warehouse, why people mainly use data warehouse is basically for, it's mainly used for like analytic workloads, because it's actually fast for, it's designed for analytic workloads mainly. So it's a little bit faster, actually quite faster for analytic workloads, and or also BI workloads as well, business intelligence workloads, right? And then when we talk about databases, so these are actually mainly for operational workloads. So obviously if you are working in a company, and then if your company has like a website or e-commerce store or any kind of application, they will probably be using the databases as the operation for the operational workloads. Okay, or not just operational workloads, you can also say applications, your applications storage as well. Okay, and then when we talk about like data lakes or lake houses, these are lake houses are actually like a little bit newer, and then these are kind of like hybrid storages. Okay, so hybrid storages, and then they have like proper storage, common storage, open storage format underneath, and then they'll have some query engines, and then they will support modern data architecture. Okay, so they are like literally now everyone is using them as part of their modern data architectures. You need to know about them. And then of course the final one, streaming, not just the final one, but these are most common ones that we are talking about. For the streaming retention storage one, why we normally, what's the purpose of them is like we normally use them as a we normally use them for temporary real-time event storage. Okay, so we normally use them for temporary real-time event storage. So you need to remember this. I mean, nothing will happen if you don't remember this as well, but it's really important to understand the types of storages and their purposes, means like when you have to use them or for which purposes. Okay. um, because because now you can see, right, now you can already feel, okay, now if you have to do something for raw or branch or archival processes, then you probably might have to use object storages, because they are kind of designed for that, right? And then if you have to go for like analytic workloads or BI workloads, then you probably might have to go with data warehouses. Or if you are designing modern data architecture or hybrid storage, if you are looking at hybrid storages, then you probably might have to use lake houses, because as they say, lake house, you know how this term comes. Okay. So this is basically data lake plus warehouse, right? So basically what used to happen is like data lakes are actually, you can dump anything in data lakes. Okay. But in data warehouses, they support like only structured data. But at the same time, if you want to get the best of both worlds, then they came up with lake houses. Okay, that's a smart one. And but don't worry, like if this feels like a lot, we'll obviously walk through it, with the examples, and of course we'll also talk more about each single topic. Like we'll probably talk about only object storage or data warehouse or databases in the respective upcoming videos. Okay, but this video is more like a overall intro to storage. Okay, overall intro to storage, and what you need to be like worry of, what you need to always keep in mind. So it's for that purpose. Okay. um, yeah. And so and then um, and then one more important question that we need to address is, why you might be thinking, and so now you already know understanding storage is little bit already, it's getting more, because so we started with the idea that the storage is just a place to like store the data, and then now we understand there are, okay, different types of storages available, and then each of them have like different purposes. And then as per your purpose, and then as per your requirements, constraints, you have to pick the right storage for your use case, right? And then one more important question we have to get it we have to get is, or we have to answer is, why storage is actually hard to get right. Okay, let's see why storage is actually hard to get right. Okay, so let's try to understand this. And again, I'm saying, if this feels like a lot, don't worry at all. And some of the things you will learn through experience. Even when I started my career as a data engineer, like back like 8 or 9 years back, I didn't knew much at all. And my background is basically from electrical engineering. So but I had always interest in programming, but at the same time I didn't really knew the fundamentals or the basics behind everything. And then it took me like almost, I would say, like 7 8 years to learn everything. So don't worry at all. And then obviously I'm not saying it will take the same amount of time for you to learn. I probably think you'll be like pretty smart, and it might take like few months for you to learn, but you have to be like passionate about learning always, and about the technology always. So let's see, coming back to our topic, like let's understand why storage is hard to get right. Okay. And I would say the challenge itself is not just about not just about storing the data, basically because you by now you might have understood that any system can do that. Okay, the challenge is storing the data in a way that it supports. Okay, the challenge is that storing data in a way it supports growth, business uses. Yeah, and then of course it should be like performant. Yeah, and then it should support like proper governance, and it should be governable. And then it should be cost efficient. Okay, the most important as well. Okay, so what I'm saying is, um, so the challenge is actually not just about storing the data. Basically, now you know that we have different kinds of storages available, and anything can hold the data. But the challenge is, uh, the growth, scaling, and then business uses, whether it supports your business use cases or not, whether it is performant or not in some certain situations, you know, um, whether it is governable, and whether it is cost efficient. For example, there will always be some kind of, as an architect, there will always be some kind of trade-offs you might have to make, okay, between performance and cost efficiency. Like sometimes some of the things can be like super performant, but at the same time they will be like really expensive. Then at that time you need to like get your priorities and get your requirements right in order to make a decision. Okay, and then the thing why we need to talk about all these things is basically, if you don't think about all these things in the early stage, you might have to pay later. Pay later in the sense, not just in terms of cost, but in terms of like re-architecturing your platform. Okay, and re-architecturing your entire platform means, like, imagine you might have to like do so many migrations. You might have to stop supporting your business. You might have to keep your analytics or analytics loads on pause for some time. So basically business might not be able to like get some value out of it, and we don't want that to happen, because the the whole reason for all because the whole reason for whole data platform or data engineering life cycles existence is to provide value to the business people, right? So if we are not able to do that, then it's basically waste of time. Okay, so that's why we have to, before making any kind of decisions, so we have to think. But at the same time, I would say, um, there is something called as analysis paralysis or decision paralysis. At the same time, you can obviously end up spending so much time just about thinking the stuff. Okay, sometimes it might be smart to just get into the stuff and then figure out as you go. But sometimes at the same time, it's really important to spend your time, take your time, analyze properly, get requirements right, get your constraints right, know your constraints, know your limits, and then know how much budget you have, and then make the decision accordingly. Okay, so yeah, that's one thing we have to talk. And then there is probably one more thing I want to talk, which is understanding, okay, access pattern, in the sense, for understanding the access patterns, we have to understand, types of data. In the sense, I don't know what's the right title for this, but then there is hot data, then there is, for example, warm/lukewarm data. Okay, and then there is obviously the final one. Any guesses? Okay, cold data. Okay, so there is hot data, there is warm data, and then there is cold data. So there is a slight difference, or there is actually like quite a lot of difference between them. Um, so the first one, what do I mean by hot data is, so if you have to access some kind of data frequently, if you have to use it frequently, okay, sometimes like very seconds, or if you have to access or use the data very frequently, in the sense like seconds or milliseconds or something like that, then that kind of data is basically hard data, because it is getting accessed like frequently, it is getting read or written frequently, so that's why it's hard data. And then when we talk about like warm data, warm data is this is used a little bit occasionally, I would say. Occasionally, in the sense, not fully occasionally, but it's like your daily reports or weekly reports, stuff like that. And then cold data is, of course, you won't be accessing it frequently. This is basically hardly getting accessed, right? And then if you have to talk about examples for hot data and warm data and cold data, let's start with the example for cold data, okay? Because I literally have the example on the top of my mind. So for example, let's say there are some tax records, there are some tax authority. So basically in each and every country, unless until it is Middle East or something like that, so or maybe in Middle East as well, there might be tax authorities, I don't know. um, so every country will have some kind of tax authorities, and they will be maintaining some kind of tax records, right? But then obviously no one will maintain tax records in a place where tax records from like 50 or 40 years back or 30 years back or even 10 years back, they won't be maintaining it in a place where you have to access them frequently. Even if you show, if you have to store them in some kind of like hardware shelves, you probably will store them at the top of the shelf, right? You won't store them at your eye level or you at your hand level where you can access them frequently, okay? Right, because those are old ones, the chances of you accessing them would be like less. That's why you keep them in a place where you don't have to access them frequently, right? So and in such cases we use the cold data storage, okay? And then when do we use warm? In the sense, for example, if we are doing like some kind of weekly reports or trend dashboards, then we should still access the data, but then we are not going to access it like every second or minute, right? So then that should be like in a warm storage, okay? And then when we talk about like hot data, so this is actually getting access like frequently, like every second or every millisecond or every minute, okay? So this data must be stored somewhere where it is like fast to access, okay? So these are the access patterns, okay? For example, if you talk about like live sales numbers on, for example, let's say Amazon or Uber ride availability, where we have to see which rides are available or where is your car on the map and stuff like that, then we have to use the hard data storage, okay? So and yeah, that's one more thing. And okay, as a data engineer, I would say, as a data engineer or any kind of engineer, if you are working with data, if you are any kind of engineer who is working with data, then basically I would say your mental model should be, you should always try to store the data in a fastest place necessary, but the cheapest place possible, okay? So what I'm saying is, you should try to store the data in the fastest place necessary. Oh, sorry, spelling mistake. So you should always try to store the data in the fastest place necessary, but okay, and not but and the cheapest place possible, okay? Yeah, and the cheapest place possible. So of course it should be like fast to access, but then also at the same time it should not break your bank or your company's bank, I would say, okay? So it should be like fast to access, but then also at the same time it should be cheapest place to store, okay? So yeah, that's again one more important point like that we need to discuss, okay? Probably I would say this is also one of the most important points that I might have emphasized or that might have come out of my mouth today. um, yeah, and then thing is, let's get into the final part of the video, which is, for example, if you are a if you are an engineer who is just entering into the data engineering, or if you are a junior data engineer who already started your career, or even if you are a mid-level or senior level data engineer, if you don't know, like if you are still asking the question like where should I put this data, that's totally fine, okay? But then in order to find the answer to that question, like where should I put this data, you should always find answers to other questions like Okay, again I think I'm repeating probably. You should find the answers to the questions like how will this data be used. Okay, how will this data be used, okay, and maintained, okay, maintained, scaled actually, and also governed. So if you, as soon as you found the answers to these questions, then you probably might have got the answer to other question as well, where should I put this data, okay. And then you know what, actually let's look at the detailed considerations or detailed questions that we have to ask, before making the decision or in order to make the decision. And then let's try to close this video, okay. So some of the questions you kind of need to ask is basically um, some of the questions or some of the key considerations, I would say, okay. Some of the key things that you need to consider, or some of the questions you have to get the answers for before making the decision is, you have to understand, is the storage compatible with the expected read write patterns, okay. So you need to know actually expected read write patterns. So how often the data will be read or written to the storage. So you have to understand that, you have to get the answer to this, whether people are going to read the data very often, or whether they are going to read it like every second or a millisecond or every minute or every hour or every half a day or every month or every week, or what's the read pattern and how often are you going to write the data, and what kind of write types are you going to do. For example, if you are constantly updating individual records, for that a relational database like maybe Postgres would be fine, okay, or would be actually great. But then doing the same thing, like if you're trying to update like same individual records many times in a day, and in an object storage like S3 buckets or a blob storage would be like super slow, okay. And that might even be fine, okay, for some of the people or for some of the requirements, okay. And you also need to obviously like consider cost, because if you are going to do so much writes on the object storage, on especially on the single line level, okay, then it might be like costly, okay. And then one other question you need to understand this, is, will this become a bottleneck later, okay. Will this become a bottleneck at later point of time, okay. So you need to understand that. See, for example, let's say if there is a CSV file which is sitting in like S3 like buckets, or or in ADLS containers or S3 blob, and which is like which has like 10 GB of data, and that might be fine, okay. But then let's say that at the 10 TB storage, querying it becomes like slow and expensive, right? Unless you use proper formats and indexing techniques like Parquet and Delta, stuff like that. But otherwise, it might become a bottleneck, right? But at 10 TB, I would say it will still be bottleneck if you like literally, even if you do any kind of indexing or whatever it is. So you have to like really be careful, okay? And then some other things you need to understand is, you need to understand the technology behind the storage, okay. So you need to understand the technology behind or beneath the storage. You need to understand how it behaves, okay. For example, the most common mistake that I saw in many places is, sometimes most of the teams, what they do is they try to use the technology in a ways it is not actually designed to be used for, okay. One of the common mistake, unfortunately, is, if you treat like object storage like S3 buckets or ADLS or blob storage, not ADLS, like blob or GCS, as a transactional database, then it might work, but it will be like really really painful, okay. So you don't want to do that, right? So you need to understand the technology behind the storage, like how it works and how it behaves. And then you need to get the one more question, okay. Like you need to understand can the storage system scale if the data in your organization, if it grows in the future? Okay, so you need to understand about the scalability. Okay, so of course there are a lot of things that come into picture, like vertical scaling and horizontal scaling, and the different types of storages. We are not going to, this video is not for that. um, but yeah, but you need to question about the scalability as well. Okay, because for example, let's say there is a startup. It might The startup might begin with SQLite, or a single Postgres instance, which is fine at that point of time. But let's say 6 months later, or a year or 2 years later, they might have like they might if the startup becomes successful, they might like get some millions of events or transactions. And then most of the time, if you are still using wrong kind of storages for the job, then basically your dashboards might time out, or your analytics might be like really slow, and you don't want that to happen, right? So basically, whatever the storage you support, most of the time I think it should support growth. Okay, so it should not collapse under that. It should literally support growth. Okay, and then some other questions you have to get right is, uh, yeah, will the downstream users access data efficiently? Okay, downstream uh, downstream will the downstream users access data efficiently? Okay, let's try to understand what I mean by this. What I mean by will the downstream users access data efficiently is, um, yeah, so basically, let's say if you have like a team of data analysts, um, or if the data analysts like had to wait, like for example, like half a minute or 1 minute or many minutes like for a dashboard to load, then basically um, they will basically what they do is they will export everything to Excel and work offline, right? So, and why they might have to wait like half a minute or a minute or many more minutes is basically, if you don't pick the right storage, then your loads or your jobs will obviously be like slow. So yeah, you don't want that to happen. So you need to know how the downstream users access the data, okay, efficiently or not. So you need to know that. And then of course you also need to know how does the storage is going to handle schema evolution. Okay, the most important point. Okay, so how does the data storage is going to handle schema evolution? For example, if there are schema evolution in the sense like if there are like structural changes to the data over time. So if source systems are adding new fields or removing the fields or changing the data type, or changing the order of the fields or position of the fields, then how does your storage is going to handle that? Okay, so you need to know that, otherwise it will probably like break all your data pipelines. Okay, so you need to know that. And that is actually one of the most common scenario that I see in production systems, like very often, way often, even nowadays actually. So so obviously I would say like no one can design the super perfect, ultra perfect system always. But thing is, you need to have a plan and strategy for failure. Okay, you need to always expect failure and then design for it. Okay, so that would be nice. So that is one more important question you need to get it right, or get the answer at least a little bit. And then one more important thing related to schema as well is, what is the schema model does it follow? What, so whatever the storage type that you are going to choose, what kind of schema model will it follow, or does it follow? Okay, so don't get confused like when I say schema model. There are I would say, or as far as I remember on top of my head, there are probably like three types of schema models that are available. One is schema-on-write. Okay, one is schema-on-write. One more is schema-on-read. Okay, and one more is just flexible schema. Okay, yeah, but from the naming, so I'm sure many of you might go with like flexible schema. Flexible schema, you probably many of you will think like flexible schema would be good, right? It depends. Okay, so it depends. So it really depends, depending on the use case. Okay, and remember, like we always need to like take into consideration all the things, right? Like growth, business performance, governance, cost efficiency, and whether we should support hot data needs or warm or cold data needs, and then we need to pick. So we should not just blindly pick flexible schema because it sounds nice or flexible. um, yeah. So what I mean by schema on write is, schema on write is basically, for example, like any kind of databases or warehouses. You know, they have like strict rules for storing the data. Before storing the data, you have your data should be in this format alone. Okay, it has to comply with the format. On everything. So so this is basically strict rules. Okay, and then schema on read is like, for example, data lakes. You have to put any kind of files into your data lake, but then you will add schema to it while reading the data. Okay, that's why it's called schema on read. And then flexible schema is like it's like for example, key value stores like MongoDB, okay, or any kind of NoSQL databases. Okay, so they are flexible schema. Okay, and each has their own trade-offs. Okay, so yeah, it's not like one is better than the other. It depends. It all boils down to our requirements and constraints, and what do we want. Okay, so yeah, and of course the final question, maybe not the final, but the final thing that I'm probably going to talk about is like you should of course also focus on compliance or legal requirements that the storage supports. Okay, so yeah, so these are some of the points, and of course you can also see, you can also ask how does it support like metadata. Okay, or lineage and all that stuff. Okay, yeah, there might be probably more, but these are some of the important ones like that I remember. Yeah, and then thing is so yeah, now finally like to say, there is basically no universally best storage available in the market. Okay, the right decision depends on the data size. Okay, the workload type you want, and then the access patterns. Okay, and then basically what is the cost tolerance you are looking at, and then what are the compliance requirements you are looking at, and then what are the business priorities. Okay, and mainly the business priorities. Okay, and sometimes cost might not be a problem to business. If it is actually giving you more business value, then you might not care sometimes. But yeah, you should take cost into consideration always. It is, otherwise it is going to hit you later, now or later. So and basically I would say in matured platforms, or in mature platforms, storage always most of the time I end up see it becoming layered. Okay, not a single choice. Okay, but what people end up doing is they will they will choose different kind of storages for different layers. Okay, and like let's say, what do I mean by different kind of storages for different layers is, let's say if it is for raw ingestion needs. Okay, if it is for raw ingestion needs, then people might go with object storage. Okay, OS is not operating system, but object storage. Okay, and if it is for clean data, or your transform layer, or your silver layer, or something like that, people might go with lake houses. Okay, if it is for serve layer in the data engineering life cycle, if it is for analytics or BI, then people might go with warehouses. Okay, for different layers, different kind of storages. And if it is for for machine learning features. Okay, sorry, if it is for machine learning features, then people might go with feature store. Okay, something like that. Or if it is like for archival archives, then people might go with AWS Glacier, or basically not like that, basically with cold storages. where you have to access the data like very hardly or infrequently, then you might go with the like cold storage. And the thing is, let's conclude this video. Actually, I think it's getting too much. The so if the final takeaway I wanted to like take away from this video, or from this content is, like, as a data engineer, your job is basically not just to store the data. Okay, your job is to store it intentionally. Okay, intentionally in the sense, your job is to store it intentionally in the right place for the right purpose, while planning for scale, cost, and usability. So you should always plan for scale, cost, and usability, and then you should always store it in the right place for the right purpose. Okay, for the right business purpose. Okay, and always plan for scalability. Okay, and basically thing is, so you might have, by this time you might have understood from all this all this text on the screen, you might have understood that storage is not just a single decision, right? Storage is basically a strategic decision that you have to take, by considering everything, like requirements and all the key considerations that we talk about, all the constraints and your business purpose and your access patterns, users patterns, your cost and performance and scalability. You have to consider, and security. Actually, I'm so sorry, I totally forgot, I totally missed the security, most important point. Okay, you have to consider all these things and then make a strategic decision. Okay, so you should not be like, so next time I hope, like, when someone asks you like, where do you store your data? Okay, where do you store your data? If your company is storing generating the data for next 5 years, like, abruptly, then where do you store your data? I hope next time when someone asks you this question, I hope you don't answer, you don't give out the technology name. You'll probably ask them like so many questions, in written, and then get the answers to that question, and then give the recommendation accordingly. Okay, and thing is, if you get the storage right, you might again wonder, okay, like do we really have to consider all these things? I would say, actually, yeah. Okay, you have to consider everything. Okay, because if you get storage right, everything downstream becomes easier. Okay, and if you get it wrong, the platform becomes actually slow and fragile and expensive, and you might eventually has to re-architect or rebuild it. Okay, so yeah, and storage is also one of the important component in data engineering lifecycle that will kind of overlap with all other stages. Like, if you have to do ingestion, you basically have to collect the data from source systems and then put it into storage. If you have to do some transformation, you have to read from storage and then write it back to storage again. And then if you have to serve the data to the customers, you have to read back the data again, and then you have to serve it. So it is basically interacting with all the different stages in the data engineering lifecycle. So it is really important to make a strategic decision about the storage. Okay, and yeah, so let's end this video, and I hope you have learned something from the video, and yeah, and if you think like this helped you think more about the storage differently, and if you think like this content helped you think more like a senior data engineer or a data architect or principal or staff data engineer, you know then please please like the video, and please share and subscribe the video to the channel. And what, actually, I'm to be honest, I'm actually really curious about what kind of storage systems are you working with today. Whether I actually want to kind of know from you whether you are working with warehouse or a data lake or object storage, or a mix, or what kind of, I want to hear from you on what kind of storage system you are using in your job, or whether it is layered. So please comment down in the comment section, and I would really love to see what kind of storage systems you are using at your job. And I'll probably come back to you with one more interesting video. And if you like this video, again, please like the video, and comment down in the comment section, and share it with your colleagues, and please subscribe to the channel if you like this content. And thank you so much. See you again.